Hey everyone, can you hear me? Can someone say like yes or no in the chat window if you can hear me through the live stream? Okay, great. All right, so this is our first live stream. Sorry for the technical difficulties. Obviously, this is a bit new to us, and I've been trying to get this all put together, on a short notice. Hopefully everyone's staying safe from the coronavirus, and hopefully we're going to learn a few things here with Edson Yagna, who is going to be talking about Quarkus here in a few minutes. But before we do that, we'll just quickly go through Java news as usual. So let's just get that going here. So, yep, as mentioned, this is coding that sparks joy with Quarkus. And yes, as I mentioned, Edson Yanaga is Director of Developer Experience with Red Hat, and he'll be doing his presentation on Quarkus here. And again, as always, welcome to the Kansas City Java Users Group. Red Hat, we thank Red Hat for sending Edson to come present to us. And also, it would have been providing food, but of course, we're not meeting in person today. And even though we're not meeting in person, we still thank YRC for providing us the space for so many years. And of course, Pivotal as well for sponsoring the group itself. So the big news this month, of course, was Java 14 was just released yesterday. There's a few big features, records, which is in a preview, and as well as pattern matching for instance of. I kind of touched on this from the last month, or not, I guess I didn't, but I think, covered this in the last month. And also switch instructions have been made standard. But pattern matching, oh, I thought I had a slide, but what's interesting, pattern matching, I thought I had a slide on it, but I guess I must have accidentally removed it. It's going to help reduce a whole lot of boilerplate for uh, in our and a lot of the code that we have to write. I'll try to provide a link to it in the Meetup group chat, just so people can look at that, because I think this is going to be one of the kind of exciting features that are going to be coming here pretty soon in the newer versions of Java as more of this pattern matching is added. No big releases. I guess the only big release is that Quarkus 1.3.0 was recently released, but Edson will, of course, go into much more detail on that. And I just didn't have enough time to really find any other major releases in the immediate time. So. Yeah, I think we had examples. I was pointing that in. I accidentally forgot and deleted that slide or something. So yeah, I'll get that added back in. Thanks for mentioning that, Justin. But yeah, other news. I don't know if anybody wants to put into the chat window if there's any other news they want to share before we continue on. Or as maybe someone types something out. There are a couple of conferences that are coming up here next month because of all the concerns over coronavirus. A bunch of conferences have either been postponed or canceled, but a few have kind of quickly stepped up to provide a virtual experience. I guess I have this in the wrong order, but we have FillOverConf on the 21st of April, and you can go to it at this link. And I also have this slide deck already in the Meetup group chat or in the comments for this meeting maker in the Meetup site. And then also all the talks online on the 15th of April. I believe these are also both free, and you can read more about them on that site. I think they're both kind of still putting together their speaker lineups, but definitely something to do. And of course, I guess now you don't have to travel for them, so that's at least pretty nice. Also, a few of the other local meetups are also going online. GraphQL, KC, they're going to have another meetup here on the 15th, and it's going to be building an award-winning graph-based web application. And again, if you go to the slide deck, you can click on that link to sign up for it at the meetup on their meetup site for how they want to do their online stuff. And again, I guess like anything we miss, give a few moments here, because I also know there's a little bit of delay as well for anything that people want to share that are coming up or anything like that. Yeah. Going to be passing it over here to Edson pretty soon. I thought I had this all set up correctly, um, but I didn't. So actually, we might lose this stream here just for a moment, in which case we'll quickly get this posted, the correct stream. But when it backs up, Edson will be here and he'll be giving his presentation. So yeah, I guess we'll try to get that started now.
Stream started. It's green. Okay, full. Hopefully, we'll see my image on the stream soon enough.
There we go. Yeah, you're up there. So yeah, you're good.
You're good? Yeah. Oh yeah, I can see myself. Okay. Okay, thanks Billy. Thanks for all the organizers of the Kansas City Jug for having me. Unfortunately, I wasn't able to visit you, but here I am virtually. So I hope everybody has your own like a bottle of beer, so we can just cheers for that. I'm using water for now, but I'm going for wine later. And today we're going to talk about Quarkus, everybody's new favorite Java framework these days. So let me just try to share here. Okay. So let's do some slides, but be warned that this is almost a full live coding session. So we have very few slides because the excitement about Quarkus is about coding. So that's why before I start, let me ask, I don't know how many of you have heard of Maria Kondo, but of course the sparks joy I got from her. And Maria Kondo basically says that if something that doesn't things that doesn't spark joy in your life, you should just think about that, thank, and leave behind, because some very old practices in the Java world, well, maybe for example waiting forever to try to restart applications or to deploy or something like that, these kind of things should be left behind because it's all about sparking joy these days. Some interesting facts about me. First, my Twitter handle is at Yanaga. I'm Brazilian Japanese, which means that all of my grandparents are Japanese, but I was born and raised in Brazil. I'm also a Java champion and a Microsoft MVP, and as far as Google can tell me, I'm still the first and only one. And just pick your favorite Java jokes, because we know we're used to that. If you're a Java developer for some old time, even you might be the one telling these jokes, but I've heard this kind of jokes for a long time. So for example, we have this very nice cartoons, and I usually like to say that Java developers are very good, are very proficient in social media, because Java developers have a lot of available time, because we have to wait, we have to code, we have to save our files, we have to start a Maven build, which is going to take forever. Then after that, if we want to check the results of our job, we're going to have to stop our application server, we're going to delete the files, copy the files, start the application server over again, wait for it to warm up, then we issue a request with the browser just to check that we made a typo, and let's start it over again. That's why Java developers, they have a lot of time to do tweeting, Facebooking, Instagramming, Slacking, and other things that waste a lot of time. But this waiting time is in the past, because with Quarkus, everything is just a matter of sparking joy, because with Quarkus, everything you do, you just save and it's automatically there. So what I'm meaning is that with Quarkus, yes, it's supersonic, subatomic Java, and everything happens in a matter of milliseconds. But instead of just talking about how Quarkus is or how Quarkus does the things, I want to show you the joy of programming with Quarkus. So let's skip the slides for now and go back here to my browser. So your new favorite website on the internet, it should be quarkus.io. You have a lot of extensive guides, very helpful introductions, documentations. We have a lot of ways for you to participate in the Quarkus community too. But I want to get started with that. So if you click here in Start Coding, you'll be redirected to this page, the Quarkus code generator. And let's try. You have to type some boring stuff. For example, group ID, Red Hat developers. And let's try artifact ID. I'm going to say KCJUG, and we should be good to start. So let's generate my application. I'm going to download the zip file, and once it's here, just open my terminal. Let's unzip this KCJUG file. You can see it's a traditional Java Maven project. Now I'm going to open my new favorite IDE, which is Visual Studio Code. It's very lightweight, because being lightweight these days is super nice. And I've added the Java plugin, which is developed by Red Hat 2, and the Quarkus plugin to my IDE. So you have a lot of goodies for you to be more productive using Java, using Visual Studio Code. So that's the stuff that I'm using right now. So I open my IDE. You can see that if I can get my example resource, which is just a hello world endpoint, and let's start the magic. So the Quarkus magic starts when I type this magic keyword, which is mvn quarkus:dev, which will start Quarkus in development mode. So the first time you have to compile your Java file, so it might take longer, but you can see development mode of Quarkus is started in 1 second, a bit more than 1 second. But of course, we can do much better than that, because the average reload time of Quarkus when using development mode, you should be expecting something in the order of 100 milliseconds or 200 milliseconds at most. So, and the more you use Quarkus, the faster it gets. So now we have development mode enabled. Let's see if my application is working. Let's go here to localhost 8080. Yes, my new cloud native application is ready, and my hello world endpoint is here. So yes, it's returning hello. So let's go back to my code. And what's the nice thing about development mode is that, as I said before, you just code and automatically you see the results in your working machine. So let's say, let's switch hello to hola, which just happens to be hello in Portuguese and Spanish too. I'll just go close here, save the files, go back to my browser, refresh, and it's already there. And how long did Quarkus take to reload? It took approximately 500 milliseconds. It's good, but it can be better. So let's see if we can improve these numbers. What else can Quarkus provide for me? Or this is a very plain, simple, static hello world endpoint. Let's try to be async. For example, if I wanted to do something async, I could provide out of box, say a hello async, and return completable future dot supply async, and I want it to hello, I'm async, and I just save the file and just get endpoint, and it's going to produce for me media type text plain. Okay, and let's try to add another path here, path/async. Okay, I think it's good enough. So if I just go back here to my, oops, I will save the file, go back here to my browser, hello/async, and I have an error. But luckily, Quarkus provides very informative error message, so you can clearly say that here, well, on line 24, you forgot a semicolon, you had a typo, so the syntax is incorrect. So if I just go back here on my code, you can see actually I have an additional closing parenthesis. So I've just saved the file, and you know, sometimes you get your stack traces, you have to scroll forever, try to find your error. Quarkus, with the Quarkus error message, we invert the stack trace, so you always have the most meaningful message first before having to dig and scroll your screen. So I just saved the file. Let's try to refresh this endpoint, and yes, Hello, I'm async. And another very interesting feature of Quarkus is you can blend synchronous, you can blend asynchronous, and you also can add reactive in the same code. So today, we just released Quarkus 1.3.0.final. So Quarkus is the latest, 1.30 is the latest addition to the Quarkus versions, and we have a lot of goodies in these versions. Of course, every single release, which is very fast in terms of release cadence, we have more features, and Quarkus is always striving to try to be even faster and even smaller. So for me to be able to blend reactive, we added a new API on Quarkus 1.30, which is called Mutiny. So let's try to add another extension. And think about extension as a Quarkus capability. So if I decide to add here REST Easy Mutiny, which is our new reactive API. I just decided and tried it today. It's working great. So I just need to refresh my class path here. And you see, I have a synchronous endpoint here. I have an asynchronous endpoint here, and I can have a reactive endpoint in the same class file, in the same class. So let's add. I'm going to produce again media type.textplain. And I can have another path here. Let's say this path is reactive. And what is the return type? So now I'm going to use a new type called uni. And this uni is going to return a string. Reactive. Just in case it's hard to see, let's try to scroll it up. So hello reactive. How do I create a uni? Well, the easiest way for me would be uni create from. And let's just supply the item statically. Hello, I'm reactive, and it should be enough for me to create a React endpoint right in the middle of this plain old Jagstar-S endpoint. So let's see if it works. I just go back here to my browser, and remember, I added an extension, I added a Maven dependency, and I didn't have to restart Quarkus. So Quarkus is still running there, and I can go here /reactive. And yes, hello, I'm reactive. So Quarkus, whenever you have a change in your project, Quarkus detects that, and when a new HTTP request arrives in your server, Quarkus just decides to restart everything. Okay, so and to be very honest with you, this wasn't a planned features of the Quarkus framework, but after Quarkus was already running, the engineers decided, oh my, Quarkus is so fast to start. Why don't we add this very nice feature that whenever we have a change, we just detect that and restart the application server? Well, that's what happens. That's development mode. So we don't have any kind of magic. We don't disable anything fancy. We don't have class loader substitution or fancy stuff. We don't have magic. It's just a matter of whenever you receive a request, we're restarting the server, we're compiling the classes, we're starting Quarkus over again, and it just show up very quickly for you. So you can see that right now Quarkus restarted again in 500 milliseconds, which we could consider is pretty good for development. Actually, I would say that anything sub-second with your development, like just saving and reloading, should be quite productive enough. And some people might be arguing that, well, Quarkus is so fast because you're only doing like a very simple demo. It's just static strings, and no enterprise Java application is just enterprise enough even if you don't add a database. So let's try to add a database to our project. And before that, I have a MariaDB instance running here. I have an empty database. Let's use my database SparkJoy, and you can see that I have an empty database, no tables yet. My Quarkus application is still running here in development mode. So let's try to add more extensions. So for me to be able to use a database in my Quarkus application, probably the easiest way is to first, I need a JDBC driver. So let's try to add a MariaDB JDBC driver. I also want to use Hibernate because I want to use JPA. And I want to show a new API that we're providing with Quarkus, which is not just plain JPA. We're going to use a new API called Panache. And of course, if you're using Panache, you can use all the JPA stuff that you've been using in the past 10-15 years, plus the additional goodies of Panache. Remember, Panache is optional. It's very opinionated, but I think it's worth for some specific use cases. So let's try to add Panache and whatever. We also want to produce some JSON results in our REST endpoints. So let's try to add some REST easy with JSONB. And also I want to use some OpenAPI for testing. Okay, just hit enter here. You can see that my plugin is just calling Maven with this command line, trying to add my extensions. And here you have emojis for the win. I've added these 4 dependencies successfully. And remember, I'll be monitoring the chat. So if you have any questions, you can just type here on the chat, because whenever I have some time, I'll be chatting and trying to answer your questions. So if you have a very complicated question, please post that. Even if it's a very simple one, I'll be more than glad to answer, because I know that Quarkus changes everything that you think about Java development. So I've added these dependencies. Sorry, Billy? There is a question. Let me check. I mean, how much RAM is it using? Consider the speed, I would imagine very low. Yes, I have very nice numbers about memory usage, but yes, Quarkus, the main goals of Quarkus was that we would need to be super fast to boot and reply to the first request successfully, and we also need a very low memory consumption. But don't worry about that. I have some slides showing these numbers, which some graphics, so it will be easier for you to understand. Right now, we're just focusing on the API, but once I decide to package this program and run, you'll be able to check how much memory I'm using. Okay, so yes, that's part of the presentation, and thank you very much, Bill, for asking. Okay, and right now I added those dependencies. Let's get back to my JPA. So what do I do now? Let's try to create an entity. So let's try to create a developer.java, a class, and first I will need a boring @entity, and probably I will need to type a private long ID and type an @ID and @generated value or something like that, but it is just boring. Then the getters and setters, all the getters and setters. I want to show a new opinionated way. Of course, the old way still works as usual, but since I want to show the new stuff, let's try to show Panache. So Panache allows you to create active record entities. And what is active records? Traditionally in the software development world, we had like 2 very popular persistent styles. So you had repositories, which is the one that Java developers are most used to. And you also have the active record style. So if you ever tried Ruby on Rails, or if you tried, for example, Play Framework, you know that the active record is a style where you get your entity and you mix the persistence methods inside your entity, which is not useful for very complex domains. But if you have a very simple domain or a very simple use case, for example, CRUD applications, or just retrieving entities from your database and trying to expose that to a web page, that's a very simple use case. And active record style, maybe it's a better fit for this particular requirement. But with Panache, you can do both. We help for you to do active record entities, or you can create repositories too, so I'll show that later too. But for now, let's try the very opinionated approach. And I don't need an ID because Panache entity already inherits the ID for me. And now every developer should have a name. So let's try to add a property. I could have like private string name, and I would have to type my boring getters and setters. But instead of that, think. If you're declaring your properties, your fields as private, and you're exposing everything as getters and setters, you don't really have true encapsulation. You're exposing the internal state of your class anyway. So if you're doing and you're exposing that encapsulation anyway, why can't we just use public fields with Panache? And I know we have mixed reactions when I show public fields in JPA entities, but remember, with Panache, you will be able to code like a public field, but it will run like a private property. Because we know that most frameworks requires, thanks to the Java Bean specifications, most frameworks requires getters and setters. So we are generating the getters and setters for you at build time. There's no difference at runtime, but the way that you code, we are going to simplify your code by using public fields. So stay with me, bear with me. So I have an entity, and now I need a developer resource. So let's try to expose those developers through a REST endpoint. So we're going to create a developer resource here. And let's try, actually, I can use another template, a Quarkus class. So Conrad had developers and path/developer and developers. okay? But instead of returning a string, I want to return a list of developers. And it's not going to be text plain, it's going to be JSON, okay? And for traditional JPA, I would need to inject an entity manager, create a query, then execute the query, fetch a result, and return this list. But since we're using Panache, everything is streamlined. So all I have to do is just type developer.lists all, and that's it. And I know never do this in production, but since it's just a demo, I can just retrieve the entire database into memory and show that into my web page, okay? What else we're missing? We just need to tell Quarkus our database connection properties. So I can go here to my application properties file, and luckily I already have here, thanks to my Quarkus plugin, already have a template here. I just need to type my URL, which is SparkJoy. DDBC driver is correct, username is SparkJoy, password SparkJoy, and here I'm using Hibernate database generation equals to update. And again, never do this in production. In production, you would be updating your database schema using a tool like Flyware, for example, which we already integrated with Flyware. But since this is just a demo and updating the entities on the fly as I save my files is very useful for demos, so we're going to keep it at least for now. And it should be enough for us. So remember, I just saved everything. I didn't restart Quarkus not even once. So source action, organize imports. Yes, now it looks even cleaner. So let's go back here to my browser and try this other endpoint. So hello localhost/developer. You can see why I'm issuing the connection. Quarkus connected to my database, created all my tables, and returned nothing because my database is empty so far. And just to tell you, to prove you that I'm not lying, let's go back here to my MySQL CLI, show tables. Yes, I have a developer table, and let's describe developer. You can see that I have an ID and I have a name. And if I select star from developer, it's empty. How do I know if it's working properly? Well, maybe I could try to issue some boring insert statements here on my CLI, but since we're trying to create a REST endpoint, maybe we should try to test that by inserting developers through the REST endpoint too. So let's go back to our developer resource here and try to create a post endpoint. So right now we're going to create a post endpoint, which is going to produce also media type.json. I am going to consume some media type.json, and let's create a method public response new developer, and I'm going to receive a developer. And how do I persist this developer in my database? If I want to insert a new developer through a post endpoint, I just need to make sure the developer ID is null. And I don't need an entity manager. Remember, using Panache active record style. For me to be able to persist the developer, all I have to do is type developer.persist. Yes, and it's done. Now I'm going to return response.status, let's say created. And it's very useful if you return the entity that was just created and build the response. And yes, we should be good. And how do you test this post endpoint? Traditionally, you would need a Firefox plugin for like Postman, or you would need to create a very complicated CLI command using curl. But since we're using Quarkus and I've added the OpenAPI extension, Quarkus is reading all the REST endpoints in my project, and it's generating an OpenAPI schema that already documents all the methods that I can execute in my REST interface. And since we are running development mode by default, Quarkus provides us with the Swagger UI extension. So the Swagger UI is consuming my OpenAPI schema provided by the /OpenAPI endpoint. And I know that here I have a get developer, get hello sync, get hello reactive. And it's not providing me the post endpoint because probably I forgot to save the file, no? Public post produces, yes, it should be good. Okay, let's go back. Yes, I didn't save the file, post is here. Let's go back to the questions. What is Panache? Is it Quarkus or open source? Why do you need to import Quarkus? So Quarkus is this new framework. Another way for you to think about Quarkus is that Quarkus is a framework for running other frameworks. So the REST endpoints, the JAX-RS endpoints here are running REST easy on top of Quarkus. And the persistence, we're using Hibernate for JPA, which is running on top of Quarkus. And on top of Hibernate, we added another API, which is exclusive to Quarkus, which is called Panache. So Panache enables, it's an additional layer that you can put on top of your JPA application that helps you to streamline your coding of persistent methods, queries, and anything else. And Panache, of course, is part of Quarkus, and just like everything that Red Hat does, is 100% open source. All of the source code is available on the GitHub, github.com/quarkus.io, and it's all licensed to use Apache version 2. So you can go to the source code, you can check it out, you can change it, you can modify, you can submit your pull request, which we'll be very glad to accept. So if you want to learn more about Quarkus, all you have to do is go to the quarkus.io website. If you want to learn how Quarkus is built, you just go to the GitHub repo and you learn how the magic happens behind Quarkus. So yes, Quarkus is 100% open source and is a project that was started by Red Hat. Okay, I hope I answered your question. If not, just keep pinging me here on the chat. So let's try to test this post endpoint that we just created. So you can see, I can see this, the example value, I have the schema, but the nice button for me is this one. Try it out. So let's try it out. If I click here, you can see that I can type something. Let's try to insert a developer. I'm going to say developer Yanaga and I execute that. And if I go here to my interface, you can have the, oops, I have an internal server error. And Quarkus provides very nice error messages. If you read the entire message, you see, well, you're trying to persist something to the database, but we didn't provide the transaction. How do I fix that? Since we're using Quarkus, it's very easy. I don't have to stop or start anything. I just go back here to my IDE. I just type the magic words add transactional. I save the file. Remember, always save your files. Go back here to my Swagger UI and try to execute that again. Executing, and now, yes, 201 created. You can see that I have Yanaga with ID number 1, and it should be working. So let's try to add more developers to make our test more meaningful. I'm going to add Billy here. Thank you, Billy. And execute that. It should be good. So let's try, Bill made a question. Let's try to add Bill. So execute. And the last question, Justin. So Justin, you're a developer too. Let's try to add Justin here. And if everything went well, if I go back here to my browser and localhost 8080/developer, I just hit refresh. And yes, we have 4 developers persisted on my database. And just to prove you that I'm not lying, if I select start from developer, everybody's here too. Okay. What else can we do? Well, we have a developer. Every developer these days also has a favorite framework. So let's try to add another property to our entity developer, public string favorite framework. And since it's just JPA, I can simply add like the JPA annotations column. Let's try to add a column definition. Say, well, it's going to be varchar 200, and the default, of course, is going to be Quarkus. Quarkus. And just save the file, or go back here to my browser, refresh the page, and everybody has their favorite framework. And remember that I said that even though you can code like a public field, it runs like a private property. Actually, if you do provide your own getters and setters, Quarkus is going to use the getters and setters that you provided. So if I go back here to my code and decided that now we have a new requirement. All of the developer names should be uppercase on the interface. So if I just provide here a get name and decide that a name to uppercase should be the implementation of my getter, I just save the file, go back here to my browser, refresh. And yes, everybody's name now is uppercase. And if I decided, well, let's get at another requirement, say that the favorite framework should be to lowercase. All the favorite frameworks should be lowercase. I just save the file again, refresh, and everybody's favorite framework now is lowercase. Okay, So we are using the getter status that you provided if you decide to code them, or else we are generating at build time. Remember, Quarkus is doing everything at build time, so there's no difference at runtime. Quarkus is super fast, not only development but also in production. So what else can we do? We can also provide some validation. Remember, it's just JPA and we integrating with the very nice APIs that we already have. So if you want to provide some validation, let's try to add another extension. I want to add Hibernate Validator. So I'm going to Hibernate, go here. I add this extension. Yes, it was added successfully. And if I just add an annotation here, for example, minimum, and I'd say that the minimum length of the name should be 3. So I just save the file, go back here to my Swagger UI, and now let's try to add another developer, but this time let's try to add me. And I execute that, and let's see what we have here. Oops. 500, I have an error, Everworks subclass. That's new for me. Okay. Let's try to see the stack trace from the Quarkus. Oh yes, what did I do? I forgot to add a magic annotation because Hibernate is already validating when it's persistent, but it's not showing me the error on the interface. So if I want to have proper integration, I can go back here to developer resource and say, well, just validate this here on my web interface. So I just add this annotation at valid, go back here and try to execute again. This time I have the proper status code. I have a 400 error saying, well, it's a bad request. And if you look at the error message, it's saying, well, the parameter must be greater than or equal to 3. The path is new developer.developer.name, which is very instructive, right? So we have integration from the persistent style to from the persistent layer to the web interface. That's how tightly integrated Quarkus is. Okay. So before we run other demos, I have to show that Quarkus, how big is Quarkus or how fat is Quarkus? Let's try to, for the first time today, I'm going to stop my Quarkus development mode and let's try to execute a build. And just for now, I'm going to skip the tests, okay? Because I changed the code that I didn't change the test, but never do this at home, please. So yes, my Quarkus project was built. It took only 4 seconds for me to be able to build my project. So let's go here to my target folder. So if you go to my target folder, you can see here that I have the jar, which was generated by the Maven jar plugin. I also have a runner jar, which is my executable jar. And you can see that my executable jar is consuming 355 kilobytes. So yes, Quarkus is very small in disk size too. But is that all? First, can I run this jar? Yes, of course you can. KCJUG runner. So I decide just to run this jar. And it's already started. Well, this time it's kind of slow, 3 seconds, is lower than usual. Maybe because I'm streaming, and yes, it's running. And if I go back here to /developer, yes, it's returning all the results for me. So I just stopped the server now. You mean that my entire Java application is contained in only 355 kilobytes? Not exactly. Okay, you have to pay attention that we also have this lib folder here. And this lib folder contains all of the Quarkus dependencies. So all of the dependencies that you have in your project are on the lib folder. And how big is the lib folder? The lib folder is 34 megabytes of disk size. So your total Quarkus application is going to consume less than 35 megabytes of disk space size. And why did we do that? Well, because containers are here to stay. And actually, I think that containers are so important that 5 years from now, nobody will be talking about containers because containers will become the default packaging format. And we don't do fat jars because in the container world, fat jars are a very bad idea because you're packaging your dependencies over and over again and your file is changing all the time. And you have to be honest here. Your dependencies don't change that often in the project. Maybe you change dependencies if you're changing very often. You're changing that like once a week or twice a week. If you have a stable project, you're changing your dependencies like every 6 months for that. So your dependencies are quite stable. And when you're creating containers, you want to add this lib folder in a separate layer, in a layer below your application code, so this layer can be cached. So you're only adding to your container the part that is changing every day, which is your business application code. And your business application code is consuming only 355 kilobytes of disk space. And thinking about containers, of course, we provided all the goodies for you to be able to create containers easily. So you can create containers using Docker, the Docker command line, the Docker daemon. You can also use Jib, which is a plugin that allows you to generate your Docker images without a Docker daemon. And we also provide S2I extensions. For example, if you want to generate a Docker image that can be deployed automatically to OpenShift, we already have an S2I plugin for that. Okay. So, and if you're wondering if Java developers should know how to create proper Docker files, well, we need to know how to craft them. But creating a very safe and performant container image using a Docker file can be hard. So think about that. We already provided something for you. So know that most Java developers struggle trying to create your Docker files. We already provided good Docker files for you. So if you want to run Quarkus using OpenJDK, Hotspot VM, we already have a Docker file for you. Or there's a new option. If you want to run Quarkus using, if you want to get your Quarkus project, compile this to a native executable image using GraalVM and package this into a Docker container, you can do that too. Okay. And now that I mentioned GraalVM, what is this GraalVM thing? So let's try to create another project. Okay, so another way for you to create a Quarkus project is using the Maven plugin. And before anybody asks me, yes, we also support Gradle, but I'm a Maven user because I make bad choices. And Quarkus Maven plugin, let's try to use the latest version, which was just released today, and create. So project ID is going to be Conrad Head Developers. And artifact ID remote, version 1.0, create a REST resource, yes please, default, okay, and done. You can see that I have here a remote folder. If I go back here to my folder, I can say mvn clean package, and if I enable the native profile, my project is going to be compiled using GraalVM. It's going to generate a native executable image, which means that since I'm running here on a Mac, it's going to produce a Mac native executable image. Let's run here. If you ever used GraalVM before, you know that making your project to compile successfully using GraalVM can be very complicated. Actually, most of the projects, they can't be built successfully with GraalVM, or else you need a very long configuration for your GraalVM compilation. But if you're using Quarkus, you don't have to even think about that, because Quarkus, everything that we do in Quarkus already compiles to native. You just have to enable the native profile and everything is there. And this native compilation might take some time. So while it's in compiling, it takes like 1 minute approximately. Let me show you some numbers. So Bill, remember that you asked about how fast Quarkus is or how small Quarkus is. Now we have some numbers for you. Okay, these are the numbers that I want to show. So these are some benchmarks that the Quarkus performance team executed. And regarding memory, and when I say memory, is resident set size. It's not just the JVM heap size. So we're we're checking the total amount of memory that Quarkus is consuming. So let me show you only my screen so you can check the numbers properly. So here, if you're running Quarkus with GraalVM on native mode, Quarkus is going to consume only 12 megabytes of resident set size, which means the total amount of your memory that your Quarkus process is going to consume in your machine is 12 megabytes. If you decide to run Quarkus using Hotspot VM or OpenJDK, Quarkus is going to consume 73 megabytes of RAM. And your traditional cloud native stack that you're used to is going to consume at least 136 megabytes of RAM. So depending on how do you decide to run your Quarkus application in production, Quarkus can be more than 10 times smaller, or Quarkus can be at least twice the size of your traditional cloud native stack. Okay, this is just for a plain old simple REST endpoint. So, but let's try to add some database to the equation. So if you add Quarkus plus JPA, for example, you can see if you decide to compile Quarkus with native using GraalVM, your Quarkus application is going to consume 28 megabytes of total RAM. If you decide to run Quarkus on OpenJDK with Hotspot VM, Quarkus is going to consume 145 megabytes of RAM. And your traditional cloud native stack is going to take at least 209 megabytes of RAM. So it doesn't matter which scenario you choose, Quarkus is either much smaller or much smaller than your traditional cloud native stack. So you choose if Quarkus can be like half the size or like 10 times smaller than your traditional cloud native stack. This is for memory consumption. Remember, resident set size. And what about boot plus startup time? So let's try to get some number. So what we measure here is boot plus time to first successful reply to the first request. Because some other frameworks, for example, they might be showing a very nice number when, oh, we started up in 2 seconds. But then they're doing everything lazy, and whenever the first request arrives, you have to wait forever for it to be able to be ready and reply successfully to the first request. But in this new cloud native world, well, maybe responding quickly to the first request is important, especially if you're thinking about serverless workloads where you don't have a JVM already running. You have to start from the ground and reply very quickly to the first request. And that's why Quarkus is optimized for this scenario. So how fast is Quarkus is? If you compile Quarkus with GraalVM into a native executable, Quarkus is going to take 16 milliseconds to reply successfully to the first request. If you're using OpenJDK, Quarkus is going to consume 0.9 seconds to reply successfully to the first request, and your traditional cloud native stack is going to take at least 4.3 seconds. And remember, it's not startup time, it's not boot time. We're measuring how much does it take to boot and reply successfully to the first request. Let's add JPA to the equation. If you compile Quarkus with GraalVM into a native executable, Quarkus is going to reply to the first request in 42 milliseconds. If you're using Hotspot VM, it's going to take 2 seconds. And your traditional cloud native stack, it takes so long that I had to scroll the image, is going to take at least 9.5 seconds. So that's how fast and small Quarkus can be, either if you're running in a native mode using GraalVM or if you're using Hotspot VM. So as I said before, Quarkus can be super small or super smaller. You also, regarding time to first successful reply, Quarkus can be super fast or super fast. You just decide which option do you want, but Quarkus is much faster than anything else that you've tried in your lifetime as a Java developer. And actually talking about that, we had some numbers too. We compared with other alternative languages and platforms. We just realized that regarding development time, the development experience, the time to restart the server, we're faster than Node.js, for example, to restart our server. And regarding time to boot and first request and memory consumption, we're as fast and as small in production as Go. That's why some people, for example, decided to implement Kubernetes operators. They were developing in Go. They decided, well, if with Quarkus we can be as fast and as small as Go, let's do that in Java, because Java is much more productive. So they switched their implementation from Go to Java, and I'm very happy that it's happening. This thing is happening because in the past like 5 or 6 years, a lot of Java developers, they decided to switch from Java to Go exactly because of issues with memory consumption and runtime performance. Time regarding the time to boot plus a time to first successful reply. But thanks to Quarkus, these people are able to become productive again with Java and still have this small footprint and very fast startup times using the Java language and the Java platform. Okay, so let's see if we have any more questions before we keep going. So here, are endpoint actuators like endpoints health metrics built-in, or do you need to bring a separate dependencies? Well, we have extensions for this health checks, metrics. You just need to add a Quarkus extension and it's automatically enabled. So yes, you need a dependency, but you don't need to do more than that. Okay. Or you can see that Billy is probably answered here. Do added fields in an entity pair persisted to the beta event is updated? Yes, because Quarkus, we don't do the magic here. Whenever you change your code, Quarkus is starting the application. And when the application is started fresh, your entity is already there. Okay. And I guess that's it. But Billy knows a lot about Quarkus too. And thanks, Billy. Thanks for helping here in the chat. And let me try to explain you the magic behind Quarkus. Why Quarkus is so fast here. So let's go back to some slides. Quarkus is so fast because Quarkus does everything ahead of time. So the magic behind Quarkus, or a great part of the magic behind Quarkus, is in the Quarkus Maven plugins, the Quarkus plugin. So let's see what a traditional Java application does. Any traditional Java application that has been built in the past 25 years has to do all of these steps when it's booting up. So you have to scan for annotations. If you're using annotations, you need to scan for metadata. If you're using XML files, you have to look for those XML files. Properties file scans for that. YAML file scans for that. You need to scan for all the metadata that your application might need in production. After you found those resources, you have to parse those descriptors, which means that you found classes with annotations. You get to go there. You need to retrieve the metadata that is on the annotations. If you have the XML files, you need to parse the XML files and retrieve the metadata on those XML files, and so on with YAML files or properties files. After you collected all the metadata, you need to generate the meta model. What does it mean? Well, I need to create this bean, I need to create this another bean, but this another bean has a transactional proxy. So now I have to create a transactional proxy, and instead of injecting the bean directly, I inject the transactional proxy in this other bean, and so on. So you have to build the entire bean graph into memory. And after all of these beans are properly instantiated and initialized, then you decide to just start the services. And that's why every Java application developed in the past 25 years is slow. And that's why they consume so much memory. Because you have to perform all of those steps every single time. And it is okay, because in the past, Java, we made a trade-off. We traded runtime performance. That's why the JVM is probably the fastest runtime environment on the planet, for startup time and memory consumption. Because in the past, you would have a single machine, you would have a single application server, and that application server would be started and kept running for 6 months before anybody would restart. So you could take 30 minutes for your application server to start and warm up, because it wouldn't be restarted so often. But since right now we're in this new cloud native world where you have instances being created and destroyed all the time, you have 2 instances running into production, and then suddenly you have 1 million requests coming, and oh, we have to scale. Well, we don't scale our servers up and down anymore. We scale them horizontally, so we spin up more instances of our application service or our applications. So if we have to wait 5 minutes for the application to boot and warm up, then those requests are gone. The user is already timed out or received application errors, and they move to the competition. That's why we need to be very fast regarding time to successful first reply to the request. So that's why Quarkus optimized it for boot time and time to first successful reply. And why is Quarkus so small into production? Because if you're scanning for annotations, you have to load the classes to do annotation scanning. If you're looking for XML files, well, you have to load the XML classes. Properties file, you have to load the properties file. And even though your application might never process XML in production, those classes are going to stay into memory until you stop your application. Because they're required at build time, even though they're never used at runtime. Why is Quarkus much smaller than any other application? Well, because we don't load those classes. Those classes were loaded at build time. So we made all the processing at build time. So whenever you have to start a Quarkus application, those 3 steps here, these things were already done at build time by the Quarkus plugin. So you don't have to do anything when you're starting your application. So when your Quarkus application starts, you just have to start the services because everything else is already ready. So that's basically the magic behind Quarkus. Why is Quarkus so fast and so small? Because we do everything that we do at build time. We just start the services, and every other Java framework on earth does all of these steps at boot time. So it consumes a lot of memory and takes a lot of time every time you start your application. And oh, this Quarkus thing looks very interesting. So what you said that Quarkus supports, for example, REST Easy and Hibernate. What other frameworks does Quarkus support? You see, a lot of the frameworks available, they were designed to build to do everything at boot time too. For example, Hibernate. You guess what? You have to scan for XML files, you have to scan for annotations, process all of this stuff. So Hibernate is one of those frameworks that wasn't optimized for this new cloud native world. So with Hibernate, for example, we had to rewrite a significant part of Hibernate to be able to perform fast, to be able to perform the way that Quarkus expects a framework to be executed. So, but thanks to the Red Hat engineers, since the very first release of Quarkus, we already had a lot of frameworks and extensions available for you to use in your projects that are already quarked. And when I say quarked, it means they are optimized for Quarkus. So you can do REST endpoints, you can do JPA, you can do reactive, you can do microprofile, you can do camel, you can do tracing, you can do a lot of the Kubernetes, you can do a lot of stuff since the very first release. And after released Quarkus, the first version of Quarkus, the community stepped it up. And a lot of people contributed other extensions to the Quarkus framework because everybody wants their favorite library or favorite framework to run on top of Quarkus. So now we have a lot of different extensions available for you to run your application on top of Quarkus. And as I said before, think about Quarkus as a framework for running your framework in a super fast and super small way. Does any framework or library runs on top of Quarkus? The answer is it depends. If you're running on top of Hotspot VM, anything works. The only difference is that the part that is optimized for Quarkus using an extension, that part will be fast and small. If your library is not optimized for Quarkus, it will run, but your library will be fat and slow, just like any other Java library that is fat and slow in the past 25 years. If you want to compile your executable to native, if you're using only Quarkus extensions, yes, your project will compile to native. If you're not, it depends. Most of the projects, they can't be compiled to native properly. Some of them can with some tweaking, so it depends. So if you're not using an extension, it's possible that you're able to compile to native, but it really depends on the library and your project. So we don't have like answers, but if you use an extension, yes, we can run that on top of Quarkus. Okay, also, not yet. So let's go back here to my presentation. And yes, remember I started my Maven build compiling to native before I started the slides again. My Quarkus project was built in 58 seconds. And does it run? Let's go back here. You can see that I have a runner, which is a native executable image for a macOS. It's consuming 25 megabytes of disk space. Let's start to run this application. So I just go back here, try to remote runner, and since this is a JVM, I can use the JVM parameters. I tried that before, and I can start this Quarkus application with a 6 megabyte heap size. I tried before, but it doesn't work. So let's try run with 6 megabytes. So run, yes, allow my application to start. And on my machine, on a Mac machine, it took 25 milliseconds for my application to run. How much memory is it consuming? I have an alias here. So, which is computing resident set size. And my executable is consuming 20 megabytes of total resident set size. And let's see if it's working properly. Localhost 8080. Yes, my new cloud native application is running. And /hello, yes, it's running successfully. So that's how fast and how small a Quarkus executable can be if you compile your Quarkus project with GraalVM to native mode. So let's see if we have more questions here. So I don't see many questions. So I have see some Spring. If Quarkus replaces Spring, it's a complicated answer. I'm going to show some Spring goodies here. And also, is it any JVM language or just Java? Quarkus supports Java, Java 8, and Java 11 for now. And we also support Kotlin. Okay. We could support other JVM languages, but right now we're focusing on Java and Kotlin specifically. But if anybody decided to provide a Quarkus extension for Scala, for example, maybe it could run with Scala too. Okay, but right now we support Java 8, Java 11, and Kotlin. Let's try to do more goodies. So I want to run this process here. So I want to run this guy here. Let's start again. But I want to change this port because my other project will keep running on 8080. So this one will run on 8081. So it's already running. Let's test it. /hello. Yes, it's working. So what else can I do with Quarkus? So let's go back here to my project. And I'm going to add another dependency. Let's add the dependency, a REST client dependency. I also want to provide some fault tolerance. So I'm going to add these dependencies. Added. So let's try to create a typed REST client. For example, suppose that inside my code, I want to access that remote REST endpoint hello using a typed interface. So all I have to do is go back here to my code and create a new file, and it's going to be hello client.java, and it's going to be this interface, and I just have to mimic my remote interface using the JAX-RS annotations. And for here I need to also add register REST client and public string say hello. Suppose that I have a get. It's going to produce also media type dot plain, and a path is going to be /hello. And I think it's good. My interface does everything that I need. And how do I use this in my code? Well, let's go back here to my hello resource and let's try to add another endpoint. I'm just going to, let's just copy paste this thing here. Get, and it's going to be public string hello remote. And what I'm going to do, I need that hello client, so I'm going to @inject. Actually, I can do just @rest client and say hello client and add this dependency, hello client. Okay, and that's it. Return hello client.say hello. So I have a typed remote end client. Let's just change my path here to remote. So I just saved the file and I forgot to start my Quarkus in develop mode. So let's go back and then Quarkus :dev. Let's start the magic. And I can see some questions regarding dependency injection. We are just using the CDI notation. So here, if I'm using @REST client, I don't need to do inject, but because it's implied. But I could also do @inject, for example. Okay, but REST client implies that I'm using inject. So it's injected here using CDI. And it should be good. Go back here, localhost 8080/developer. Yes, it's still working. /hello. Yes, hello. Oh, it's complaining because I tried to insert a REST client. The interface supposedly is correct, but I didn't tell my Quarkus application where is the remote server. Oh, that's my fault. But it's very easy to fix. How do? I just go back here and type these properties, com Red Hat developers, hello client /MEP REST URL, HTTP localhost 8081. Okay, save the file, go back here, refresh, and it's good. /hello is returning hola, and if I go /hello remote, yeah, it's returning hello, which is the remote endpoint. And just to be sure that it is invoking the remote endpoint, if I stop this other server, go back here and refresh, I have an exception. Connection refuse. How do I protect my code from remote failures? Well, meet fault tolerance. And that's why I like to show up the fault tolerance API, because it's very easy. Suppose that here this method has an exception from a remote method. I just add the fallback annotation, fallback method, let's be original, fallback. And I create another method here saying, well, public string or just string fallback. Return, I'm still alive. Okay, so I have this fallback here in my code. I just save the file and refresh. And yes, I'm still alive. I just keep hitting refresh because the fallback API is working for me. But if I decide to start the remote server again, yes, it's running, and refresh, well, now it's returning the remote endpoint. Okay, so I showed some goodies, but last but not least, I know that many of you are Spring developers, and I'm a Spring fan. I've been using Spring since version 1.0 beta 2, so I dedicated my entire career to Spring, and I love Spring. And I thought, well, I love this Quarkus thing too. Can I reuse my existing Spring skills with Quarkus? Well, yes, you can. That's why with Quarkus we developed the Spring compatibility APIs. So we support Spring dependency injection, Spring REST controllers, Spring repositories. We also support Spring security and Spring config. So that's some of the things that we are already supporting on Quarkus. And if you have any other favorite Spring API that you want to be included in Quarkus, well, maybe just go to the mailing list and say, well, I have this project using, because the engineers need to know what people are using to be able to implement something like that. Okay, but let me show you that. So here I have my project. Let's try to add more extensions. So I want to use the Spring Web API, and I also want to use some Spring data. And let's do it for now. Spring Web and Spring data. So what do? Here I have, let's try to create, remember that I'm using Panache. I can create a Panache repository too. But first, let's try to create a Spring developer repository. Okay, .java, and should be an interface. And whenever you have an interface, you just have to do stangs JPA repository. It's going to be a type developer, and ID is long. And if I want to create, for example, custom methods, I could public. Let's try to create a list of developer, find by name, string name. Yes, this is a valid Spring data repository, and I love Spring data. It's one of my favorite Spring APIs, so it should be working. And what else? Let's try to create a Spring REST controller. So create a new file, developer, a developer controller. And if you use it to Spring, of course, you do the REST controller. Let's try to get a request mapping. Path is going to be / Spring developer. And what else can return? We can return net get mapping, public list developer, find developers. Return, and let's try to inject. So here I have Spring developer repository. And yes, we support construct injection, but since I'm lazy, I'm just going to use an auto-wired, and I can return developer repository dot find all, and that's it. It should be good. Okay, /Spring developer. Let's run it. So if I go localhost here, Spring /developer, it should be returning, yes, all the developers persisted on my database. So yes, it works. Okay, so you can use Spring REST controllers, you can use Spring JPA repositories, and it works the same. And just to be fair with Quarkus, I'm using here on my developer resource. I'm still using, for example, Panache entity, but let's try, for the sake of completeness, try to create a Panache repository. So I'm going to Panache developer repository. .java, in this case it's a class, and I just have to do application scoped, and I'm going to implement Panache repository of type developer. Okay, and now I can have custom finder methods too. So with Panache you can choose if you want active record style, you can. If you want repositories, you can too. If you want to mix both of them, you can. We don't make any judgments. We just try to help you. So if you want to try the opinionated and very fast approach, you can. If you don't like that, well, you can keep your traditional style. Yeah? No judgments. So if you want a custom finder method, you can use public list developer. Let's say find by name. I'm going straight string name, and I just have to return a custom query. Return find. And here I would need to provide a JPQL query, and you know JPQL can be boring because select something from developer D where the .name equals something, but Panache knows that if you're in developer repository and it's a Panache repository of the developer, you are querying developer, so you can omit everything, just say that name equals to this parameter, and you say that the parameter is the name. Okay. .list, and that's it. And we did it this way because we think that this type of programming API is much better for you to be creating complex API, which is the typical use case for you to be using, for example, a repository. And how does it work? Let's go back here to my developer repository, and let's say that depending on developers, let's try to add a request parameter, actually a query parameter called Brazilian, and it's going to be a Boolean. So if I add this parameter Brazilian, it should be returning Brazilian, and I suppose I'm the only Brazilian here. So if I just decide, oh, here I have CDI working too, at inject, I have Panache developer repository. If return developer repository, find by name, and I suppose it's only me on the list of developers that were persisted here. So I just save the file, go back here, localhost 8080/developer. Yes, it's still working, but if I add this query parameter, Brazilian equals to true, it returns only myself. So that yes, we can use Spring APIs and Spring repositories, and you can use Panache repositories too, or you can mix everything on top of each other. So another common question is, does it mean that I'm running Spring on top of Quarkus? No, we're not, because technically you could, but you wouldn't benefit from running Spring on top of Quarkus, because Quarkus would be super fast and super small, and Spring would be fat and slow as usual. So what we're doing with the Spring compatibility layer is that think about the Spring annotations and interfaces, for example, as metadata. So what are we doing? We're looking for the Spring annotations and interfaces. We're getting that metadata and we're implementing that on top of Quarkus. So we're just using that for fetching the metadata, but under the hood, the implementation is built on top of Quarkus. That's why if you're using the Spring compatibility layer, your Quarkus application can still be super fast and super small, okay? And if you go to the Quarkus website, you can see here that we have, if you go to the guides, you can see that we have a lot of different extensions for you to be running. So you mentioned here health and metrics, for example. Yes, we have here for the cloud, you have health checks, you have metrics, you have serialization, compatibility, as I mentioned before, DI, web, Spring Data, Spring Security, Spring Cloud Config. And we have a lot of different stuff, and we have a lot of more being added every single release of Quarkus. So you just have to take the time and use it. And my key takeaway from this presentation is that I don't intend to teach you everything about Quarkus today, but I hope that I was able to get you excited enough so you can immediately after this presentation, you can go to your notebook, go to the code.quarkus.io website and generate your very first project. I assure you that you won't be disappointed because Quarkus is simply amazing. The first time that I was able to run MVN Quarkus :dev, I just automatically fell in love with Quarkus because it's super amazing. Okay, and let's see if we have any more questions. Question from a Meetup user: would Quarkus work in PCF, Pivotal Cloud Foundry? Well, Quarkus is just a plain old Java application. I mean, Quarkus is super new, but it is a Java application. So there is no difference at runtime. So if your platform can run a Quarkus application, yes. If your platform can run a Java application, yes, it can run Quarkus. And the main benefit of using Quarkus as your Java framework is that, well, Quarkus will be super fast and super small. You'll be able to save a lot of money. And actually, you can see at the Quarkus website, we have some blogs from customers and other users running Quarkus into production. And I believe that Vodafone, I think that's the use case. I might be wrong. You need to check the blog. But Vodafone was able to halve their costs on AWS because with Quarkus, they can run the same amount of instances with half the memory. So they cut their AWS costs by half by using Quarkus. Maybe Amazon is not happy with us, but I can assure that Vodafone is very happy because their bill lowered a lot just because of the memory consumption. So how did Quarkus achieve the fastest startup time? I guess the Billy already answered, as I mentioned before, because Quarkus does everything at build time. That's the magic behind Quarkus. Dependency injection is done at compile time. Most of the DI rules are done at build time, yes. So when you boot your Quarkus application, almost everything is already ready. You don't have to process anything. And I don't know, I'll give you just a couple more seconds, so if you have any questions, you'll be able to see that. But just in case we didn't cover anything today, or you think about any other question later, you can go back here. You can reach me in my Twitter. Oh gosh. In my Twitter at Yanaga. So if you go to this QR code, it'll point to my Twitter profile, or my email is also yanaga@redhat.com. I'll be more than happy to answer any questions that you have for me later. Okay. So, and while we do that, let's see, last call for questions.
There's a couple more, like about security, and then also Bill had one a bit higher about Spring Data.
Okay. Okay, let me check. Last one, Justin asked, how fast does Quarkus keep it up to date for security patches? Okay, Quarkus is maintained by the Red Hat team, and Red Hat is like known for their SLA for security patches. Quarkus is not yet productized, but once it is, you can count with the traditional Red Hat SLA for fixing security vulnerabilities. For most of the security vulnerabilities, if you have a Red Hat subscription, is 24 hours. For security data corruption issues, security vulnerabilities, I believe it's 24 hours. But remember, oh, but what about you said Quarkus is open source. What about the source code on GitHub? With Red Hat, everything that we do is done at open source. So if you have a security fix, it will be fixed first on GitHub. And then later, we will generate the artifacts fixed for our customers. So you don't have to worry, oh, Red Hat is going to take forever. No, Red Hat fixes everything first on the upstream projects on GitHub, on open source. And what we do later, we just get the security, the fixed jar, and we publish that immediately to customers within that 24 hours. But if you don't have a Red Hat subscription, what will happen is that the source code is fixed, but we didn't generate a new release at Maven Central yet. But if you go to the website and compile the source code yourself, you will have the security fixes in your jars. So that's how Red Hat works regarding anything that we do in open source. Okay. And the other question about Bill, so the Spring data, for example, we run ahead of time with Growl, or that's additional work? No. If you're using the Quarkus compatibility API for Spring data, it will compile to native because we have a Quarkus extension for that. So if you're using Spring, if you were using, like, I don't think there's a reason for you to be doing that, but if you were running just Spring on top of Quarkus, you wouldn't be able to compile to native. But if you use the Spring layer, that the Spring data layers, the Spring web layer that Quarkus provides for you, then yes, you'll be able to compile to native. That's one of the guarantees that you have in running Quarkus, that if you use a Quarkus extension, yes, your code will compile to native. So yes, he said, well, we did the hard work, and I can guarantee you that it is a lot of hard work to assure that it's running. And oh, I just noticed that my face is out of stream because my camera ran out of battery. So let's put the screen only. So yes, and now I hope I answered all the questions. I don't know if you have anything else for me. If not, as I said before, thank you very much again. I'm so sad that I wasn't able to visit you at Kansas City, but I promise to try to visit you later once all of this coronavirus thing is over, because I'm really eager. Billy told me about a very nice barbecue place, and my son Googled the place, and it seems that you have one of the best restaurants, best sandwiches in the world that has been sold at Joe's Barbecue. Is that correct? So I'm very eager to try that. So if you're able to invite me another time, I'll be more than happy to share some barbecue with you after the meetup. But that's all I have to do right now, and it's up to you, Billy.
I think we're good. So yeah, if you want to, I guess you have the stream over here. For now, I don't want to end it. I think we're good. So thank you very much.
Okay, I can stop here. So you can't hear Billy, but I'm going to stop my stream and hand it over to him back again.
Yeah. Let's see if it. Okay. All right. I think that's it. So thank you for everyone for coming, and hopefully we'll get some of the kinks worked out for next time, and we'll see you next time.